Hello, I'm teacher Ivan and I welcome you to our mathematics lesson. Today we shall be looking at relations, mappings and functions. A relation is a statement connecting domain and the range. This statement is either in words or in terms of mathematical operations. A relation may be expressed in three ways. One, we can use papygrams, or we can use mapping notation, or we can use arrow diagrams. We are to look at all of these. Starting with will be papygrams. What's a papygram? Papygrams are used to show relations whose domain and range belong to the same set. And the papygram contains a set of values forming a certain relation in an enclosure, which is in the most cases a circle or an oval shape. For instance, example 1 says, draw a papygram for the set of values. This is the set of values showing the relation is a factor of. Meaning, in this set, we have numbers that are related by this relation. So, if we are to represent this relation on a papygram for this set, this is how we shall do it. So this papygram is drawn in form of, can be a circle or an oval shape, and now we shall feed in our elements of the set. So this is 1, 2, 3, 4, 5, 9 and 10. The relation we are showing is a factor of 1. What is a factor? Because before we answer this, we must know what a factor is. A factor is a number that multiplies another natural number to get a particular result. So meaning that a factor of 10 means that a factor of 10 is that number that multiplies another natural number to get 10. And that is 1 is a factor of 10 because 1 times 10 gives us 10. Then 2 is a factor of 10. 5 is a factor of 10, but 10 is a factor of itself because 10 times 1 is 10, so 1 and 10 is a factor of 10. 2 is a factor of 10 and 5 is a factor of 10. Therefore, each number is a factor of itself, since 1 times that number gives you that very number. So each number is a factor of itself. Then factors of 4. We have 1 is a factor of 4. We have 2 is a factor of 4. Factor of 2. 1 is a factor of 2 and 2 itself. Factors of 3. 1 is a factor of 3 and itself. Factors of 5. 1 is a factor of 5 and 5 itself. Factors of 9, we have 1, we have 3. So that is how we shall draw. You can draw a bigger one and you space them so that they don't look untidy like mine. But that is how we show a certain relation on a papygram. A papygram is a cyclic shape. It can be an oval shape containing all the elements of the domain and the range in that one shape, and the relation is shown in that very shape. Then another relation is a multiple of. I want you to show that a multiple of, but the trick is you must know what a multiple is. Actually, a factor could be the opposite of a multiple, but every number is a factor of itself, and similarly every number is a multiple of itself. So as you're doing that, take a note of that crucial note. Otherwise, that is how a papygram looks like. Then we come to arrow diagrams. Arrow diagrams show the relation between each first element and second element. It shows which elements are related. But for arrow diagrams, we must have two sets, one having the domain and the other having the range. For instance, example 1 says, given that set A is having 3, 4, 5, and set B has 4, 12, 16, 20. They want us to draw an arrow diagram to show the relation is a quarter of. So, an arrow diagram has two major sets. We have the domain. The domain is always on the left, and then we have the range on the right of the domain. And now we are showing a relation is a quarter of. So what is a quarter goes to the domain. Domain is having set A. So that is 3, 4, and 5. That's the domain. Then the range has 4, 12, 16, 20. Someone may ask me, how did you know that elements of set A are the domain set and those of set B are in the range? According to our relation, we are supposed to show, because we say that the arrows match from the domain set towards the range. So we cannot put these ones in the domain, because if you look at the two sets, the elements of set A are the possible quarters of those of set B. That's why I cannot bring elements of set B in the domain, because according to the relationship we are supposed to show, it shows that those of A are the quarters of those in B. So you must also keep that in mind as you are working out. And therefore, the relation we are to show is a quarter of. This is set B. So 3 is a quarter of 12. And 4 is a quarter of 16. 5 is a quarter of 20. So that's what we call an arrow diagram. And in an arrow diagram, we have relations. This is one-to-one relation. We may have one-to-many. We may have many-to-one and many-to-many, as we shall see in more examples. But that is the arrow diagram. Then we also have example 2, which says that Draw an arrow diagram representing the following mappings below using given domains. So in part A, the domain given is a set of 2, 4, 6, 8, 9, 11, 12, and the relation should be x mapping to 4x minus 1. So meaning that here we are given the domain set, but we are to find the range set using this mapping. And therefore, how is that done? We have to first get, we have the domain range, and we must get this is the domain set. We must get the range set as well before we draw the arrow diagrams. But the range set will be determined basing on our function or mapping, whereby we are told that x maps to 4x minus 1, meaning that 2 will be 2 times 4, which is 8, minus 1 to give us 7. 4 times 4, 16, minus 1 to give us 15. 6 times 4, 24, minus 1 to give us 23, and so on and so forth. Then after obtaining the range set, we now draw the arrow diagrams and say this is x mapping to 4x minus 1. This is the domain and this is the range. So we feed in the range set, the domain set and the range set, and then we start mapping. So that is arrow diagrams. In number 3, we are told that find the unknown values in the arrow diagrams for the mapping x equaling or x mapping to 2 into x plus 1. Yes, so if we are to find, this is our domain set, this is the range set. So meaning that the values on this side are showing x, and the values on this side are showing 2 into x plus 1. Meaning if we are to find d, we shall say that d equals or d maps to 2 into d plus 1, which gives us 16, and therefore we can find d. The same applies to b. So in the even c here is a set is 13, meaning that 13 is what maps to c, but 13 must map, or c equals to twice into 13 plus 1, which will give us the value of c. That is arrow diagrams, and I request to pause from here so don't miss out by simply subscribing and hitting the bell, such that you get notified whenever we have a new lesson, in order to learn together as we enjoy together. I'm Teacher Ivan from Wuuna Educational Services. Please, I beg you to go to our homepage, subscribe to all those YouTube channels, such that you don't miss out on anything. Otherwise, we are on Facebook, we are on TikTok. Just search for Wuuna Educational Services and subscribe, follow, like, and join the Facebook groups. We will be very glad if you join our academic family and walk your academic journey with us. Otherwise, see you in the next lesson. Bye bye.